welcome to the RAS 2025 webinar. For those of you that don't know me, my name is Kristy Riley. I'm the Division Chief of the Hydraulics Division at HEC. Our division is responsible for developing HEC-RAS. This week was supposed to be the HEC-RAS Users Group here in Davis, California, but unfortunately, we had to cancel it due to travel restrictions. But it's really important to us that we are communicating with all of you advancements that we're making in RAS. So we decided to host a series of webinars. This is our first one today for RAS 2025. We'll also hold one for bridge hydraulics. And then we'll do one for stormwater pipes. Before we get started, I do want to introduce who will be presenting today. We have Alex Kennedy, who is the lead developer of HEC-RAS 2025. Alex has been with the RAS team for the last 14 years. We have Zach Morris, who is a software developer who's been instrumental in the user interface development. Zach's been with us for the last 5 years. And then we also have Stanford Gibson, who is the core sediment expert, but he is also an expert in blue water modeling, as he calls it, and he'll be presenting today as well. And Stan has been with the RAS team for the last 20 years. So with that, I'm going to hand it over to Alex.
Hello, everyone. My name is Alex Kennedy. Let me start sharing my screen here. And I am the lead developer on the RAS 2025 project. We've been working on it for a few years now. We're quite excited and happy with the progress that we've made. And I kind of want to open up before we launch the software, before we do software demos. The standard preamble is that the rule number one of software demos is you never do a live software demo, right? There's going to be crashes. There's going to be bugs. Things inevitably go wrong. Murphy's Law applies. So the very first thing, if you haven't seen the software, besides dark mode, is that we want to make every piece of this product that we can a GIS-centric, map-centric point of view. So it starts with your recent projects list. We have a kind of scrolling list of your project history, what you've been working on. This applies to everything we do, from importing files to example data sets. Everything we do, we want to be map focused. We want you to be drawing in the map. We want you to be spatially anchored. We want you to understand where you are applying boundary conditions to your model. We want you to understand everything that makes sense in a geospatial fashion. So on the left-hand side of our screen here, we have our 4 entry points into the product. We have our new project page, which we'll go through in a moment. Open existing projects is pretty self-explanatory. It does actually open version 6 projects to some extent. That is very, very kind of early days of development there. We're working on model importers. So if you try it out and something goes wrong, please don't be surprised, but do report it as a bug and let us know. Example data sets. This gets into kind of right next in importance to our JS map-centric point of view. Is we want example data sets and other network-based activities to be right in front of you. So we want to host things here at HEC that we can, that makes sense. We want the interactivity of, hey, is this very easy for us to help acquire and us to download from NOAA, from USGS, from all of those sorts of data sources. We want to make everything that makes sense and is good for us to work on and helpful for the users to be available right in the software. Example projects is the first kind of opening out of that here. They are hosted at HEC. They come with little descriptions, tags. We want tagging for things like, hey, does this have sediment, right? Does this model 1D, 2D hybrid? We want you to be able to use example projects to narrow down to, oh, this will help me learn how to use the product, how to use RAS. But I'm going to back out from here and start by creating a new project. One of the very first portions of the new project page here is that we will make you select a projection up front. Part of the JS first philosophy, we want to be able to show you maps. We want to be able to know where your data is in the world so we can help apply our network understanding to it. So I'm going to grab one of my files and drag it on here. We have many different ways of being able to select a projection. You can search for them by name. We want to supply a way to find projections on the map, but that'll be coming a bit later. In this case, just dragging another TIFF I had. I didn't necessarily know what projection it had, but I knew it had a projection. So drag and drop that file onto there, and it scrapes the projection. It's an AEA projection there. And I'm going to be working in the Ohio Miss area and create the project. So the very first thing is it tries to identify a center of mass of the projection. In this case, yes, it's a bit south, but it got the longitude approximately correct. And base maps right available in the UI. So this is one of the things we are, again, hosting here at HEC, and we want to make as much of modeling life as easy as possible so you don't have to leave the software where it doesn't make sense to. I'm going to start off by creating a new terrain layer, very much like version 5 and version 6. The terrain is an empty bucket when you first create it. So we are supporting raster formats right now. We're in the process of adding our terrain vector mods back. But when you first create it, it is a very quick, just empty bucket here. And on the right-hand side, we have our how to add data plus button. It has a couple options. I know someone else is going to be showing the USGS importer later, so I won't show that off too much, but feel free to hit the plus button and import a file. So drag and drop also works with a variety of files, including mass drag and drop. So I am going to be shift selecting these TIFF files that I have brought in from a different model, drag and drop them onto the importer button, and it loads all of them up again in a GIS-centric UI that you can pan around, zoom in, see all of your data. In version 6, one of the heavy pain points here is that if you brought in your raster data out of order at any point in time, you had to redo the entire import process. Anyone who's ever received a slightly improved channel data set or didn't realize that their terrain layers were out of order has to start over from the entire beginning of the process and bring that data in. In this case, it doesn't matter. You can reorder them after the fact. So I am going to just hit import here, brings all the files in parallel. This is one of the things that we're really, really proud of, really happy with how fast our raster processing is. We've put a lot of time and energy into the basics of raster processing. Hey, what can we do with these 16, 32 cores in your machine? Now that we have 64 gigs of RAM, how can we make every part of the modeling experience better? So I'm going to zoom into this area, and I happen to know that the USGS 30 meter is pretty rough in most of these areas there. So you can see a bit of, this might be one of the boundaries that we're talking about here, and it appeared organically, just by happenstance, towards the top of the layer list. I'm going to drag it back down to the bottom of the layer list, and now has our more advanced, better processed data in front. So this, we are hoping, really helps people out with building terrain models, and especially allows you to manipulate your model after the fact, add better bathymetry as you get it, and reduces that inner loop, that inner cycle of improving your terrain model. One of the other things that we're really, really happy with for the new kind of network connectivity, network focus portion of the UI is the NLCD data we have hosted here at HEC, and it is available right from within the UI. So if you have your domain, your terrain set up, and you want the NLCD dataset, you can hit import, and it'll download from our website, flip to your current terrain extents, and have that right there. Now, I happen to know that this is a very, very large area that takes a couple minutes to download, so I went through and did this ahead of time. But I promise this button does in fact work. And I'm going to just grab the NLCD data that I had downloaded ahead of time, drag and drop it here so you can obviously import any integer data set that we have access to. I'm going to hit import, and much faster, takes a couple seconds. While that is happening, you're welcome to keep using the user interface. Oh, I'm not sure if you're getting this. I've got a WebEx notification that my CPU usage is high right now. That's part of what we're focusing on, is making sure we can utilize all of the cores available in your machine. So while this is doing its final reprojection and importing stage, I kind of wanted to touch for a moment the classification layer system is bringing the NLCD in as integer codes. So right in version 6, we tried to marry these two concepts of these integer codes versus these floating point parameters of n values that you would typically use them for. We have those separated out right now, and they're separated out for a pretty good reason, in that you can now use classification NLCD datasets for other things as well, like as we added percent impervious, and as we've added sediment and erosion deposition, as other pieces of our model have started to use these types of data sets, we tried to take a broader spectrum look and say, oh, how can we split out these two concepts? So obviously, they're still very, very important for n values, we wanted to make sure that we had kind of early assistance for being able to apply them to end values. So we're going to just say create end value layer from this. And as part of the classification and interpretation separation here, I will turn classification layers off and end value layers on. And this is just a reinterpretation of the classification. So as you are panning and zooming here, the layer created instantly, because it's not a separate layer. This isn't another gigabyte floating point data set that's sitting on your machine. And when you start to get into terrain vector mods and you really digitize your channel correctly, you have to re-import and reconvert to a floating point raster. This is all happening on the fly from your base classification data set, because you've told us, hey, I would like you to take this understanding of the world, this NLCD data set and any hybrid vector layers on top of it, and then pull in and convert it to a floating point data set. I will review a couple more things. One of the things that you can really do to help us here is report bugs. So it is available from the help menu up here, but also available from the main user interface bug report. We will not be able to respond to the vast majority of the bugs that get reported. I believe we're in the 600 or 700 bug report kind of space in the last 7 or 8 months that the software's been out, which is wonderful. It has helped us fix actually hundreds of bugs, because what happens when you hit the bug report is your description really, really helps, but we also attach a log file. So we get to see error messages that are happening deeper in the code that don't come forth to the user as effectively yet. So please use this liberally. Attach screenshots in particular if you have a mesh that is going poorly. You can hit the geometry or mesh generation button there, and we'll pop up a second portion that says, oh, please attach a mesh if you think it would help us diagnose this. This is really, really wonderful, and this is how you can best help provide feedback. If something's just confusing, feel free to report a bug and say, hey, I didn't understand this at first. It's a perfectly valid way to kind of send information to us that we take in aggregate and say, hey, if a lot of people are having this issue, even if it's not a bug technically, we will relook at this user interface and try to make it better. So I think this sums up most of what I wanted to talk about here. And with that, Stan, I may bounce it over to you.
Thanks, Alex. That's fantastic. All right, I'm Stanford Gibson. My job today is to just walk you through a demo and show you as many of the cool things as I can. These guys are pushing new stuff every day. I'm just going to create a brand new project. So here's the splash screen. Here's all the projects I've been working on, but we're going to just start from scratch. So new project, we'll give it a name. Let's call it demo USACE. And as Alex said, everything's geospatial, so there's so many benefits from that. The cost of that is you need projection up front. And so, the easiest way to get a projection is to, strip it off of a data file. But I think that it's underrated to just go to spatialreference.org, and I just typed in Willamette, and I got this ESPG number. I can just copy that, drop it in here now, and I have a projection. All right, so I'm gonna zoom in to the Mackenzie River. We're using this because the USGS has flown LiDAR and green LiDAR here, and that's because there's a lot of restoration work going on. And so we're just gonna build a little model of one of the restoration projects they've done. We like this because the green LiDAR gives us the ability to bring in terrain and bathymetry. So here we are, but I don't have any terrain, but that's okay. It's real easy. I'll just create a terrain just like Alex said. And then we're going to come over here and we're going to open USGS importer. This is the coolest tool because we're just going to pull in our terrain. And so I'm going to say query area. And this just shows me all of the products that are available here. And so you see, we really like these data sets because they have the green LiDAR here that gives us just what's going on in the channel, but also then they've got the LiDAR over here for everything else for the floodplain. So I'm just going to press shift and I'm going to take everything that I want, and it will bring in the little channel, the bigger ones, and the great big ones. And so that's all going to come in, and that takes about, I would say, 6 minutes, which is kind of super fast if you're working on a project. That's not super fast if you are doing a demo. So I have done the baking class here. I did this beforehand. And so what came in here, you notice that I selected probably I don't know, like 25 different products. But when it came in here as 3 merged DEMs. And these merged DEMs, what the guy Alex and Zach are doing is they looked at the products that are like each other, the products that have the same scope and scale. And in order to get rid of the seams, they've merged them into like products. So basically I have 3 types of products here. What order I want to be in? Well, the cool thing here is that we not only can kind of look at this over in the components, but there's a terrain editor. And so I'm going to open the terrain editor. And when I go into the terrain editor, then as I click these, they show me what is the actual extent of each of these. And so this is kind of the big like course background. This is the green LiDAR just in the channel. And then this is the floodplain. And so if I just move this up, you know, if we go in right now, we've got no channel. But then if I move this up, now our channel is going to show up. And so then if I just go back to my map, now I have everything I need. And this is the restoration zone that I'm interested in. If I turn on my background map, you can see this is a pretty early, pretty big stage 0 type restoration. They've loaded this thing with wood. I guess we'll see what happens in a couple events. It's pretty novel. We're just going to build that. Okay, so the first thing you do in the current version of RAS is you draw perimeter. We're going to do that. We're going to draw perimeter, but we don't call them perimeters anymore. Let's call this course grid. Everything is arcs. The perimeter is made up of arcs, and that's incredibly powerful. It just takes a little getting used to. And so I'm also going to build a conceptual mesh. The conceptual mesh is essentially the trellis. It's the skeleton that the mesh exists on, and that comes in arcs. So I'm going to start out with an arc up here at my upstream boundary. Let's put it, say, right here. I actually know that the flows don't actually go above this ridge. And then I'll have another arc. And I'm just going to make this like conservatively high water to make sure that I contain all my flows. And then I like this nice narrow section as my downstream boundary condition. And then I'll make a 4th arc that connects. And now you essentially got what we considered a perimeter, except it's got a lot more spatial intelligence. And RAS 2025 recognizes that this is a region. And so over here, you've got the arcs and the regions. A region is composed of multiple arcs, but I don't really just want to mesh this. I've got a channel in there and I need to get some channel detail. And again, I could take 8 minutes and you could watch me digitize this channel carefully, or I can show you the cool import feature. So let's do that. So I actually pre-made my my channel. So I'm going to come in here and I'm going to say import polylines and polygons. And this is a shapefile that I made yesterday. And as we import it, you can see that I've gone in and digitized this channel. Now, this is a very simple shapefile that I'm bringing in. So you don't need any of this cool import or merge stuff, but I need to talk about it because this stuff is really cool. We're going to probably be bringing in shapefiles, at least for our like larger perimeters. And sometimes when you bring in HEC data, you'll have like 2 watersheds that are adjacent, which means that they'll have overlapping arcs. And so what the merge and import does is it looks for overlapping arcs, it looks for topology, and it'll make some of those decisions for you so that you don't end up with illegal data. Okay, but I'm just going to import this. All right, so now I've got my channel in there, and now I've got 3 different regions. I've got this channel region, I've got the left bank region and the right bank region. I've also got these like vestigial arcs here that I need to get rid of. And I know that what you really want to do is right click this and delete. That's not how we play anymore. We are just going to select and press the delete key because that's much more straightforward. Select and press the delete key. All of this workflow takes a little bit to get used to, but I have to tell you at this point, I've been doing this for about 6 months, and now this is straightforward, and going back to RAS 6 is awkward. Let me just add a couple more things here. I want to add this high ground for the road. So in order to start a new arc along an arc, I'm going to press Control, and that's kind of the big thing you need to know because there isn't another way to do this. And I'm going to trace this road because this bounds our restoration site here. And then it'll automatically kick back together. And then I think we really need to capture, just because I'm familiar with this data set, I really need to capture this channel right here. And so let's do that and just tie that into the high ground. And I'd be much more careful if this was an actual project, but we're good to go. All right, so I'm ready to make my mesh. And you'll notice that there are a lot of different ways you can make a mesh now. Triangles is the way that we're gonna just kind of do the overbanks, but I don't want triangles in my channel. I want my channel aligned with flow. So I'll come to my channel and I'll choose what we call quad. It's represented by a square, but it's not a square. We're gonna align these with your area. And so I've got, everything else is going to start at 100. So I'll let my longitudinal spacing be 100, but I only want 3 across. And so I'll change that to count and I'll say 3, give me 3 across. And so now if I make my mesh, you can see that that's not a bad mesh that we put together in just a few minutes. And then we can definitely scale up and scale down later, but I'll show you that. Okay, next, we're going to add our boundary conditions. And so one of the big differences here is that the geospatial reference of the boundary conditions are in the boundary conditions themselves. So it's not like you have to spatially reference them in the geometry and then they have an awkward connection. This is fantastic. But there's a couple of things that are going on here. One is that we're going to define the time window for the boundary condition itself. And then you can do sub things if you want. But so you have to do the time window first on the boundary condition scale. And then that actually gives you more flexibility later. So this actually ends at 4/1/2025. Was a pretty big event in March of 2025. So we'll do that. And then this is going to be 3/14/2025, and we'll create this. And now we get our boundary condition data. We'll come over here and I'm going to add my upstream boundary condition. And I'll come back to that. And then I'll go add my downstream boundary condition because that's going to be easier. And on my downstream boundary condition, I'm just going to give it normal depth. 0.045, again, because it's a workshop, not because that's the boundary condition I want. And then up here, I have some flow data. So I'm going to put in my flow data. And the flow data is 15-minute flow data. So I'm going to change it to minute and make this 15. And then here's my data in Excel. I got this just off the USGS website and just put in Excel. We'll eventually be able to just download these from the GS website. But for now, there are our data. All right, so I have a boundary condition. We need a plan. And so we'll call this plan course grid, and we'll choose our geometry and we'll choose our boundary condition. And then it's just going to adopt our time window, except I don't want that time window. I want it to run a shorter time window. I just want the first event. So I'm going to switch to a custom time window and make this 3/19 and create. And I already know what I've forgotten. I've forgotten the end value because I forget that all the time. So I'm going to go in and put in an end value. And you can obviously be much more careful about this, but just to get this off for a demo, let's make this 0.045. All right, and then back to our plan. And it's telling me that my boundary condition doesn't cover the full time step. So that's really helpful information. Let's make sure, because I made that 1 minute instead of 15. Okay, thank you for that error message, Zach. That was super helpful. And so now I'm going to switch it to GPU. We're not going to talk much about that, but this is a very exciting button because it's going to use my machine's GPU. And then I am going to compute. And then while I'm computing, I also want to come over here and I want to show you. So this is a course grid. This is just kind of exploratory, but of course I might want to do this with a finer grid. And this is really the beauty of the way we're doing meshing now is I can come in here. Let's turn that off and turn that on. And I'll come into my conceptual mesh, my layer, and it says global cell size modification. I'm just going to have all of my cell sizes. And then I'll come in here and regenerate mesh. And you can see that it just went in and redid my cell size. Hey, let's do that again. And now I have a really tight cell size that I'm happy to work with. But let's go back to our original that is still baking in the oven. And one of the cool things is it doesn't matter that it's not done running. I can go look at it right now. So let's turn on the depth and let's visualize this. Okay, and so then we can look at our result before we're even done. And you can see that we're kind of filling these side channels. It's going pretty well. I made a more detailed version of this with the more detailed grid. Let's just look at a little bit at some of the results. The guys have added the ability to query time series. And so now we can look at the time series of depth and water surface. And so here's our depth time series. And then the other thing we've got now are profile lines. Profile lines are really helpful. I'm going to go and I'm going to choose my velocity. You can ask it to plot your results. And there, and so we've got our velocity in those two different channels. And then you can ask it to sum up the flow and give you a flow time series. And so this is the flow time series in both of those channels across those cells. All right, then that's a pretty good model. But let's say that you like that mesh, you like that model, but you can't deliver in 2025. You want to actually go back to RAS 6X, but you want to keep this mesh because this mesh is so much better and easier to use. Okay, well, we'll do that. We'll go to mesh, we'll go to export, and export the HEC-RAS mesh version 6. And we'll pump that out. It will drop it in the exports folder. You can see I've already done that once this morning. Now, if we go back to RAS Mapper, I've created a model that can accept this. And so here's RAS Mapper. And let's create a new geometry. Okay. And then we look at our new geometry. We're going to go to our 2D flow area, our perimeter. Let's start editing. And we'll go to our 2D flow area. And this button here, import mesh, that allows us to go here and get the mesh that we just made, give it our end value. And this mesh is locked, so you can use the mesh in 6X just as it is. And so I've done this and I ran this morning. We're actually getting a really nice result from the velocity distribution through the restoration zone.
Hello, everyone. I am Zach Morris. I am just going to cover some of the new cool features we're working on that are kind of currently in development or were just released. And they're mainly UI related. I do the UI work for RAS 2025. I have got a model open here, and one of the new features, one of our programmers, Jet, he added some new ways to visualize results. So in the top right, you'll notice there's two new buttons. One of them is velocity arrows, and the other is particle tracing. So I can turn on velocity arrows, zoom in, and you can see velocity arrows. He made them curved. Some people wanted them curved, and so he put a little work into making sure the little arrows curve. And then what I think is cooler is the particle tracing. So if I zoom out here, we can see little particles. And he's added a little drop-down menu on the right here where you can, change different things about the particles. So right now I have it on screen units. So if I zoom really far out, the particles don't look too slow, and if I zoom really far in, they don't look too fast. But I can change it to physical units, and they move very fast in physical units. So what I can do is there's a little time scale slider. I can actually slow them down. If I go back to screen units, you can change how fast they go. You can also change little things like how long the particles last. Slow them down. And the amount of particles. So if I want a lot more particles on screen, I can do that. If I don't want them to last as long because they're staying on screen for too long, I can also tweak those little settings. So some of the visualizations you're familiar with in 6 are slowly making their way into 2025. And then the next thing is we are working on improving table data entry. So in the boundary condition editor, this table has, for the last 8 months since we released alpha, the HEC-RAS 2025 alpha, has been pretty painful to work with. And it should hopefully be better now. Interaction and editing is improved, but to show off some of the upcoming capabilities, in the latest version of the alpha we released last Friday, so just a few days ago, in tools, you can open up a spreadsheet. And this is It's kind of an Excel-esque spreadsheet functionality directly inside of RAS. So as an example, I can copy my boundary condition data and I can paste it into the table here. And you can see I've got all my boundary condition data. There's a little screen blocking me. Here we go. It's got about 1,000 entries in here right now. What I can do is we've also added little formulas, again, just like Excel or Google Sheets, whichever you're familiar with. So I can type equals and then a little square bracket, and we'll have documentation on all of this on our website soon. And the first number is the row. So I'm going to reference row 1 and column 1 and multiply by 2. And so you'll notice multiply to 20 by 2. And if I copy this cell, select the whole column, paste, it'll multiply every value by 2. We've also added some functions that operate on ranges of data. So I can come in here, I can take the average of rows 1 through 999. We'll just do column 1. And so you can see I'll get the average of all of column 1. And we've got a couple other cool functions in here. Mean, average, median, those sorts of things. Standard error, standard deviation, any simple functions that work on ranges of data or an individual number we've added. And while this is kind of in a standalone little, spreadsheet environment, the hope is that this sort of functionality interacting with your data starts to make its way into all of the tables in RAS, and it's just easier to either manipulate, view, get statistics on all sorts of data in RAS. Okay, and then the next thing that's new, some of you, if you've opened the software in the last, I'd say 2 months, since 2 releases ago, you'll notice a new Project Explorer tab. So one of the problems that RAS 6 has and RAS 2025 also has is that this tree on the left where you control your map with gets cluttered very quickly, gets overwhelmed with layers, very untenable in larger models. And so we're going to move a lot of that complexity into the Project Explorer here. So you can see it has a list of all my layers, basically anything that's a file on your file system. And this is going to have, it already is starting to have lots of functionality like folders, searching, filtering, and I can click on a geometry. Let me put this a little easier to see in light mode. I can click on a geometry, get some basic quick actions, some basic information on the geometry, and a little preview of what the geometry actually is. I can click on a terrain, get a preview of the terrain, and some other information about it. And so why is this important? Well, we'll get to that in a second, but some of the other things real quick that the Project Explorer will have is I have another model open. Let me get this guy. Come on. There we go. Okay. So in the Project Explorer here, I've got many different geometries, and so you can see I can click. There's a dense region of cells here. This allows me to click back and forth, see the difference between 2 geometries. But some of the cool stuff we're experimenting with is I can actually expand out this geometry. I can see all of the backups that we are already creating for your model, for your geometries, directly from the Project Explorer, and I can click through them, and it will actually show me previews of the backups through time. And there's a little button up here where you can restore a backup if there's a previous version of your geometry you want to go back to. And so a lot of this functionality interacting with your model on a more like project-wide level, lots of those functionalities will come to the Project Explorer. All right, so why is this important? This has so far not solved the problem of a cluttered map or a cluttered tree on the left-hand side here. So you'll notice this is currently hidden in the latest versions, but in an upcoming version, you will be able to click this little map button in the top left-hand corner and create multiple maps. So I'm going to create a second project map, and you'll notice I now have 2 map windows open. One of them is blank, just showing OSM, and the other has my terrain and results on, you'll notice the tree responds to which map I've clicked. So the left map, I have the terrain and the profile lines on. On the right, I've got nothing turned on. So I could turn on a geometry here and zoom to it. This still doesn't solve the problem of a cluttered tree. So we have more maps than just what you're used to. So what I can do is I can actually create a new blank map that has no layers in it. And this is where the Project Explorer comes in handy, because I can drag a result over to my tree. And now this result, let me put a geometry over here as well. That geometry and result are now for this map on the right. And so some other cool things about that, Stan showed off briefly that there are new plots. And so this will also be how you control new plots within RAS. And so I have a profile line drawn. Let me select the layer. I can take this profile line, plot a result profile. So here's our result profile. It interacts, goes up and down as I scroll through time. But let's say I want to compare two results. I can just go to my Project Explorer, grab a different result, turn it on, and we'll notice I've got two light green lines in my second result here. I can see in the chart next to my original result. And eventually we'll have ways to synchronize the time step between these two results. But this new map system, hopefully, will make working with your projects, organizing your work way easier, interacting with charts and maps across the software way easier. And yeah, that's what I got. Those are some cool new upcoming features.
So there are two questions that I get asked very often. And so we wanted to try to do our best to answer both of those. One is, when are features going to be available in RAS 2025? And the other one is, when can I get training on it? So I have two slides to hopefully answer those. In terms of our development timeline, we have 3 years scoped out for what we plan to do. We're about halfway through FY25, so some of these things have already been completed, but our goal is to have an official release of RAS 2025 by fall of this year, hence why we named it 2025. And in that official release, we'll have mesh generation advancements, precipitation, wind, atmospheric pressure, basic structures, basic terrain modifications. We're going to have tools to be able to import your version 6 models. We recognize that there has been an enormous investment in all the current versions of RAS models. So we do want to make it as easy as possible to bring your models from 6 into 2025. However, we do want to caution you that this is a different model, and some things are fundamentally different. And so it's not going to be the same as if you were converting from a version 6.5 to 6.6. There will be some more work, but our goal is to make it as seamless as possible. So we're working on tools to help with that, and we'll be working on that throughout the years as well. We do have our GPU solver. Again, that's something that we will continue to work on throughout the years in advance. And then we'll also have a 1D, 2D hybrid solver. At the end of FY26, we plan to have advanced terrain modifications, advanced structures, advanced mesh post-processor tooling. We'll have advanced 1D solver and mesh enhancements. Up until that point, everything will be 2D, but by the end of FY26, we'll be able to create a model in 1D. We'll have improved boundary conditions, initial conditions, and breaching capabilities. By the end of FY27, we will have a new tool for geometry and boundary condition clipping, where you can import and export. So the idea behind this is that if you have a watershed scale model, you would have the ability to export a small portion of that, have a standalone model where you can make refinements, and then if you wanted to, you could import that back into your larger watershed scale model. We'll also have a sensitivity analysis framework, project management. We'll have improved inundation mapping. We recognize that there are limitations with version 6 with rain on mesh mapping when there's shallow flow. So we're working to investigate solutions and implement that in RAS 2025. And then we'll also have our implicit 2D solver by the end of FY27. Previous to that, we're using our new explicit solver. I guess while we outline this, I want to kind of put some cautions on this. One is we're rewriting 30 years of code. This is an enormous effort. There are unknown unknowns, so we might hit some hurdles along the way. It's going to take a little bit of while to reach feature parity with version 6. And unfortunately, we are not immune to losing staff through deferred resignation and VERA. So this timeline was developed prior to some recent hurdles. So some of this is somewhat subject to be adjusted slightly. In terms of our training, we recognize that after we have an official release, there's going to be an enormous amount of people that we need to train. And so we are working on ways to do it as efficiently and effectively as we can, given that we are a team of 11 and we are still rapidly trying to meet all of our current deadlines of development. So we decided the best way we think to do this is to offer a class at HEC first quarter of FY26. We will work with each MSc division and have them help identify subject matter experts within their division to come to this class. It'll be about 2 to 2.5 days. We'll consider our dry run class. It's where we'll get feedback from the students. We'll make any iterations to make sure it's a solid class. And then in second and third quarter of FY26, we will be willing to send 2 to 3 people from the RAS team to travel out to each MSc division to offer the class. So we'll work with all the divisions to figure out where would be most convenient for them, because I understand the divisions will want to pull in all subject matter experts from their districts, and then the timing of when that works. And then we'll also, since the more teachers you have, the better the class goes, the better ratio. So we will ask whoever the subject matter experts are that attended that first quarter training at HEC to help assist with the class at their MSc. That way we'll have more people walking around for workshops and helping out. We are also working with the prospect course to create a new course for RAS 2025 that will be available in FY27. So our plan for 26 is to try to do a roadshow, as much training out to everyone as possible, and then 27 we'll have formal prospect courses. And I added pictures just so you kind of have an idea of who the RAS team is and who might be coming out to provide these trainings for you.